ओम ऊर्जा देवाय नमः। जय श्री राम, जय सीताराम, जय बजरंगबली, जय हनुमान। Before in this lecture we will learn about the file management system. Before going to the file management system, let's see disadvantage of virtual memory. So in its disadvantages are: it is difficult to implement because it requires algorithms to support demand paging. The second disadvantage is it used carelessly. It may decrease performance substantially instead of increasing performance. This happens when page fault rate is very high for a process. That is, the processor spends more time in swapping out and swapping in of page than its execution. And the advantage of virtual memory: it makes programming tasks much easier. Programmers need not worry about size limitation of physical memory available, but can concentrate instead on program logic while programming. Another point is that an analysis of execution of real programs showed that programs often do not execute all parts of their code during a typical execution run. For example, depending on data, a system may skip a large part of code of a program on some condition check and may never need to execute that part of code during that execution run. Similarly, during most execution run of program, a system rarely uses certain options and features of the program, such as those for handling unusual error conditions. With virtual memory mechanism, since the operating system loads part of a program on demand, the system may never need to load certain parts of the program the system does not need during a particular execution run of the program. This in turn leads to the less input-output activity than in case when the system needs to load whole program before its execution. With less input-output, each user program would run faster, resulting in a better throughput, turnaround time, and response time. So जय बजरंगबली, जय हनुमान जी की। ओम नमः शिवाय, ओम ऊर्जा देवाय नमः. So now I am going to start the topic file management. File is a collection of related information. Every file has name, its data and attributes. Name of a file uniquely identifies it in system. We access files by their names. A file's data is its contents, which is a sequence of bits, bytes, lines, or records. A file's creator and user defines the meaning of its content. Attributes of a file contain other information about the file, such as date and time of its creation, date and time of last access, its current size, date and time of last update, its current size, its protection feature, that is, who can access the file and in what way, etc. Different operating systems maintain different attributes for a file. File management module of an operating system takes care of file-related activities such as structuring, accessing name, sharing, and protection of files. Now we will learn about important concepts used for file management in operating system. The first one I would like to discuss is the file access method. To use information stored in a file, a system needs to access it and read its content in a main memory. Normally, computer systems support the following two file access method at operating system level. The first one is sequential access files. Normally, operating system is sequential access files for storage of files on sequential access storage media, such as magnetic tape. Applications can access the content of a sequential access file only sequentially. That is, a process can read the bytes or records in the file in the order in which they are stored, starting at the beginning. Reading of bytes or records randomly or out of order is not possible. An application can, however, rewind and read a sequential access file as often as needed. The second one is random access file. The random access file for storage of files on random access storage media such as magnetic tape or optical disc. Application can access the content of a random access file randomly, irrespective of the order in which the bytes or records are stored. For example, an application can access a specific byte of the file directly without reading all records or bytes before it. Random access files are essential for many applications. For example, a railway reservation system may be storing information about all tickets booked for a particular train in a single file. If a customer wants to cancel an already booked seat, reservation program must be able to access the specific record for that seat without having to read records for hundreds of other booked seats first, so that booking service can be fast enough. Now let's talk about the file operation. File operation. An operating system provides a set of operations to deal with files and their contents. Here we see a typical set of file operation. Actual set varies from one operating system to another. For example, some file operations are like create, delete, open, close, read, write, seek, get attributes, set attributes, rename, copy, etc. And we see the use of this one by one. For example, create file operation is used to create a new file. Delete file operation is used to delete an existing file that is no longer needed. Open file operation is used to open an existing file when a user wants to start using it. Read file is used to read data stored in a read file operation is used to read data stored in a file. Close file operation is used to close a file when the user has finished using it. Copy file operation is used to create a copy of a file or to copy a file to an input-output device such as printer. Rename file operation is used to change name of an existing file. Set attributes file operation is used to change user setable attributes such as protection mode of a file. Get attributes file operation is used to access the attributes of a file. Seek file operation is used with random access files to first position read and write pointer to a specific place in file so that data can be read from a written to that position. Write file operation is used to write new data in a file. Close file operation is used to close a file when the user has finished using it. So these are the operation, file operation and its usage. Now let's talk about the file naming system. When a file creator creates a file, he gives it name that user can use later to access the file. The rules for naming files vary from one operating system to another. Now let's consider the following example. For example, MS-DOS allows only up to 8 characters for a file name, while Macintosh allows up to 31 characters and Microsoft Windows allows up to 255 characters. With longer file name, users have greater flexibility in assigning more descriptive and meaningful names to their files. The second point is that some operating systems allow users to use only letters and numbers in file names, whereas others also allow special characters, sometimes bearing a few. Hence, names like letter 3 underscore from underscore Ram, remainder 2 underscore 2 underscore Sam are often valid file names. Some operating systems such as Unix uses case letters, whereas others such as MS-DOS do not. Hence, Unix operating system treats the file name Sina and Sina as three different files, but MS-DOS treats them as a same file. Therefore, a user can assign these three names to different files in Unix but not in MS-DOS. Many operating systems support file names having two or more parts with a period separating different parts. For example, MS-DOS supports two-part file names in which the first part can have 1 to 8 characters and optional second part can have 1 to 3 characters. For example, letter.txt. In Unix, a file may have more than two parts. For example, pro.c.z, where .c and .z indicate that it is a program file of C language, which is compressed using the Ziv-Lempel compression algorithm. In such file names, the second and subsequent parts are called file extension. File extension usually indicates something about the file. Applications often use file extension to check for the intended type of the file before operating on it. For example, a C language compiler may insist that the files it is to compile must end in .c and it may refuse to compile them if they do not. Some applications supply their own extension automatically, such as .doc for a Microsoft Word file and .wk4 for a Lotus 123 file. Here are some typical file extensions and their meanings. For example, .c, C source program file, .bas, basic source program file, .ftn, Fortran source program file, .obj, objective file, compiler output not yet linked, .pas, Pascal source program file, .lib, library of .obj files used by the linker, .bin, executable binary file, .bin, executable binary program file, .dat, date file, .hlp, text file for help command, online manual page file, .back, backup file, .txt, general text file, .xls, Microsoft Excel spreadsheet file, .jpg, JPEG graphic file, .gif graphic file, .wav, Microsoft Windows sound file, and .wk4, Lotus 123 spreadsheet file. So these are the extension and their meanings. Now let's talk about the device management system. For processing data, a computer must first input data and program for which it needs input devices. Similarly, to produce the result of processing, it needs output device. Device management module of an operating system takes care of controlling all input-output devices of a computer system and provides a simple and easy to use interface to this device. We describe below how an operating system takes care of these requirements. Now controlling input-output devices. A computer uses device controller to connect input-output devices to it. Each device controller is in charge of and control a set of devices of a specific type. For example, a disk controller controls disk drives, a tape controller controls tape drives, and a printer controller controls printers. A device controller maintains some local buffer storage and is responsible for moving data between an IO device that it controls and its local buffer storage. Each device controller also has a few registers that it uses for communicating with central processing unit. In some computers, these registers are part of the regular memory address space. This scheme is called memory mapped IO. In other computers, the operating system uses a special address a space for input output and allocates a portion of it to each device controller. Now to perform an input-output operation, the operating system writes the relevant commands and their associated parameter into the appropriate controller register. After loading the command into the controller's register, the CPU resumes with its normal operation. The device controller then examines the content of these registers and performs necessary action for input-output operation. For example, the action for a read request will be to transfer data from the specified input device to its local buffer. Once transfer of data from input device to the controller's local buffer is complete, the operating system uses one of the following two methods to transfer the data from the controller's local buffer to appropriate memory area of the computer. Once first non-DMA transfer, capped DMA. In this method, as soon as transfer of data from input device to the controller's local buffer is complete, the controller sends an interrupt signal to CPU. The CPU then stops what it is doing currently and transfer controls of execution to the starting address of the service routine, which handles the interrupt. On execution, the interrupt service routine transfers the data from local buffer of the device controller to main memory. As soon as this data transfer is over, the central processing unit resumes the job that it was doing before interruption. Om Urja Devaya Namah. The second method is DMA transfer. In non-DMA transfer method, central processing unit is involved in transfer of data from device controller's buffer to main memory. That is, the operating system executes the interrupt service routine, which reads one byte or word at a time from the device controller's buffer and stores it in memory. It is wasted of precious CPU time if CPU is involved in reading and storing one byte or word at a time. To free the central processing unit from data transfer operation, many device controllers support direct memory access, abbreviated as capital DMA mechanism. In this method, when the operating system prepares for data transfer operation, it writes the relevant commands and their associated parameters into the controller's register. The command parameter include the starting memory address and the number of bytes in the data. Now, after the controller has read the data from the device into its buffer, it copies it from the buffer into main memory, one byte or word at a time. It does not involve the central processing unit in this data transfer operation. The device controller sends an interrupt to central processing unit only after it completes copying the entire data. Note that in this method, when the operating system starts after the interrupt, it starts performing the subsequent operation directly because there is no need for it to copy the data from the device controller's buffer to memory, since the data is already there. So, Jai Sitaram, Jai Bajrangbali, Jai Hanumanji. With this word, I would like to end this lecture.